Okay, Lloyd, if you're ready, we might kick off. So it's Roisin here and Dr. Stevens, and we've Dr. Philip Crowley with us here. He's the National Director for Quality Improvement. And welcome to everybody online for today's webinar, which is being co-hosted by Lloyd, Provost over in Texas in the US. So thanks a million, Lloyd, for joining us bright and early there. Delighted to have you back with us. I know we did a webinar a few years back, so it's great to have you back with us again. So Philip is going to do a little introduction, Lloyd, if you want to click on the slide there.
Great. Look, it's really a great privilege to have Lloyd here with us today. Lloyd is well known to many of you, an improvement advisor with the Associates in Process Improvement. He's worked worldwide on the science of improvement, particularly in the area of measurement, and he's great multiple experiences consulting and teaching collaborative improvement across the globe, particularly with statistics, process control, and measurement. He's a senior fellow also at the Institute for Healthcare Improvement and works with the IHI on their Improvement Advisor Development Program. He has written 3 books, including the Healthcare Data Guide, a book that we use a lot here. And really, most importantly of all, Lloyd, I think, has been a great friend of the Quality Improvement Division and of the HSE in general. He's been over on a number of occasions, but most recently spent a whole week here training a lot of people here, specifically people in my own division, and we've been using what we've learned from Lloyd ever since. So it's a great privilege to introduce Lloyd to you all, and I hand you over to Lloyd now.
And just before that, Lloyd, actually just quick introductions or housekeeping. The phone number there and the event number is there for anyone who wants to dial in on the phone to make your signs a little bit better. We will have plenty of time at the end for any comments, ideas, or questions, so please use the chat box. If you click on the top right-hand corner, circled in red there, and type in your questions as we go along. And we are active on Twitter at QI Talk Time if you want to pass any comments throughout the webinar on that. Without further ado, thanks a million, Lloyd.
Hey, thank you, Rosin. Thanks, Philip. Hearing a little bit of feedback. Good to be back with you again, a chance to talk. And our subject today is going to be measurement for improvement. And I think we've done a couple talk times in the past on measurement for improvement, so I want to try to build on that and talk about some of the key ideas. So I'll start off reviewing the ideas of what's different about measurement for improvement. Appreciate the importance of time series when you're looking at improvement data. Appreciate learning from special causes. And then I'll review some examples of useful applications of different types of control charts. Okay, so that's a full 50 minutes, I think, and then we'll have time for questions at the end. And Rosin has agreed she'll monitor questions during the talk, and if there's something, I said she can interrupt me, or I'll stop if something we need to stop and talk about. So just for the perspective, when I say measurement for improvement, what do you mean by improvement? And the framework I'm using is the model for improvement, developed by API a number of years, used lots of places in healthcare. So improvement project focuses on the 3 questions. The aim, what are we trying to accomplish? A measurement system, how do we know a change is improvement? And then, the most importantly, what change can we make that will result in improvement? Improvement's about change. Measurement's there, though, for a couple important reasons that we'll talk about. So measurement at the project level is looking at the overall results of the project related to the aim. So it's outcome measures, process measures, and also balancing measures for the system that we're improving. And so those are measured and reported throughout the life of the project. But then there's a whole second level of measurement. When we're doing something with the model for improvement, we use the plan, do, study, act cycle. And so PDSA also requires measurement. We put together a plan for questions we want to answer, and then we need data to answer those questions. Often that's quantitative data about our particular change. Sometimes it's qualitative data. How did you feel about this? How well were the ideas received? And sometimes it's a subset or stratification of the project measures. So maybe this PDSA involves 10 patients, so I might look at the outcome measures for those 10 patients to see the impact of the change. So I think that's a complexity there when we talk about, ask questions about measurements and data. Are we talking about your project measures, or are we talking about a PDSA measure? Project measures throughout the life of the project, PDSA measures only while we're running a particular Plan, Do, Study, Act cycle. So just background paper, which I think you probably have been introduced to all before, called The Three Faces of Performance Measurement. This came out more than 10 years ago now, and Leif Solberg, who was a researcher and then a manager in healthcare, and then he came to quality improvement, and he sort of discovered something with quality improvement. And a summary quote there, we're increasingly realizing not only how critical measurement is to the quality improvement we seek, but also how counterproductive it can be to mix measurement for accountability or research with measurement for improvement. And so the lesson he was learning and shared with us here in the paper is that that type of data and measures that we've used traditionally, either in research environment or in our accountability performance management, may not be the best measure for quality improvement efforts. In the healthcare data guide, which I used to reference for a lot of this topic, there's a couple of examples of that. First example in the upper left is a performance measure. So this particular health system, when patients are scheduled for a colonoscopy, they want them to be completed within 90 days. This is in the U.S. system. And so this team currently, if we look at the first point on the graph, they're only about 5%. If I can move my mouse there. Yeah, only about 5% are currently getting that. So the improvement team goes to work and start doing some of the types of changes that they think should lead to a reduction in wait time. Confirm appointments, they work down their backlog, they match capacity and demand for different time periods. And what we see is only, in this measure, only a real modest increase, maybe up to 10%. And so they're a little discouraged. And the problem here is that what we're doing is adapting the performance measure for an improvement measure here. And what we want to think about, what is it the improvement team trying to do? They're trying to reduce the wait time. And so a better measure would be go directly on the right there and measure the wait time. So each month, the people that had appointments, how long do they have to wait? And we see they're starting off 150 days, 140, 148 days. Okay? And so now we can see all of a sudden we see that these changes we made have had a big impact. And we see that we have a real improvement. Now, the problem is they're still running about 100 days, which is not meeting the target yet, not meeting the goal. But the feedback for improvement should be, yes, these changes have led to a nice improvement, reduction in wait time. And so, first, don't always just adopt the goal. I mean, the reason we're working this project is because of this outcome measure, but that don't automatically make that our key measure. Always try to go to what is it we're really trying to do in the system. Second example, diabetes doctor wanted to, he'd just come from a conference and they emphasized again the impact of smoking for patients with diabetes, the negative impact there. And so they said, this is something we haven't really emphasized, so let's go back and do it. And he went to his hospital and they had a measure called percent of patients counseled on smoking cessation. And it was 100% here, 98%, 100, 100, 100, do that. So he wants to improve, okay, so he starts making changes. So how much improvement are we going to get here? Well, as you can see in this measure, nothing's going to improve. So this measure, even though it is the current measure used in the system, is not one that's going to help them say, are we improving, doing smoking reduction there? So instead, developed a new measure, a lot tougher, percent of smokers who not smoked for 2 months. Okay, now how are we doing on that? Not so good, only about 10%. So on the visit, would they say they haven't smoked for 2 months? So now we can start testing our changes and see the impact in this tougher measure. So go back. Even though this, our performance is still only about 40%, we're seeing the impact of our changes here. And so sometimes you'll get the judgment measure that's currently used, accountability measure, is often high because we want to be able to be accountable. But we'll find out is that's a lot easier question than really what we need to understand smoking for this population. So once again, don't just adopt that. Third case that we run to is when we look at patient satisfaction measures. In the United States, it's becoming standard now to do this on a monthly basis. And what we look at is a patient satisfaction percentile. So we look at how does our hospital compare to other hospitals that are like us in the group here. And so we're running about 72%, and we want to improve that. Okay, so we've put together a team that works on improving, and get some improvement, it goes down, get some, it goes down, get some, it goes down. So, you know, here we are after 12, 16 months, and we still haven't really changed this measure. So what's going on here? The percentile measure measures two things. It measures our performance on satisfaction, but also compares us to everybody else. And so as everybody else changes, that's where we get a lot of this variation in. And a lot of times the comparison group we're in, people drop out and change that. So once again, even though the percentiles, how hospitals judge, we need to move to a directly measure the problem that we're working on. We're trying to improve patient satisfaction, so just measure what percent or show satisfaction, whatever how that's defined on the thing. And now we can see the impact of our change. So we've gone from 70% to close to 90%. Now why are we only at 75% over here? Is, well, the group we're comparing to has also changed, also probably improved in this case. Okay, so judgment purposes, accountability, the percentiles are a useful measure, but for improvement we have to go directly to our level. So I think that's the first lesson when we start a measure. We're often measuring because we're having a problem with our performance measure, but we have to think through what is the appropriate improvement measure that goes directly after the problem that we're working on. Okay. In the healthcare data guide, we have these 5 general directions for an improvement project. So we think about our measures. First of all, a few key measures that clarify the aim of the improvement project, make it tangible, should be regularly reported throughout the life of the project. These are a couple outcome measures, a couple process measures, and maybe a balancing measure of those. And so they should be, everybody should be looking those throughout the project. That's what makes improvement very different than research. We don't wait to the end of the project, we do it throughout the project. Second guideline, be careful about overdoing process measures. Often we'll sit down and say, okay, we're going to change 10, 12 different things in our system, so we need to measure all those. I think we could measure those during our PDSA cycles while we're testing those, but we don't need to make all of those our project measures that we're measuring. Problem is we get borne down with the overload of measures. We spend all our time looking at data and collecting data rather than doing our improvement work. So a balanced set of outcome, process, and balancing measures is important here, but keep the number down. Third advice, plot data visually on the key measures over time. We're going to talk more about why that's important there. And then fourth, try to make use of existing databases and data already collected for developing the measures. Okay? Now that seems a little counter to my earlier advice. Be careful about using some of the current judgment measures. But maybe right now we're measuring are we meeting a 30-day wait time goal? Well, that's already collected. Well, they actually collect the time, and then they convert it to yes or no, did they meet the goal? So go back to that database and get the actual time data out of there. I think, you know, a big movement with electronic health records certainly been a mess for healthcare, but I see it starting to pay off now. More and more projects that I'm coaching on, I find out from the beginning they have data available in the electronic system, and so we need to figure out how do we best use that for our improvement project. And then if there is some additional data collection, begin to integrate that into daily work routine. So at the beginning of the project, go ahead and think, rather than develop a new form, say, let's take a form that's already being used in the process and modify that to collect that data. So when we get done the project, one of the ways we're going to have sustainability is to continue monitoring these measures. So let's go ahead from the beginning and think about how do we move those into work routine. So I think follow those 5 points there. We put together your measurement system for the project, and I think you have a good chance of being successful on measurement. I mentioned different types of measures. Outcome measures are most important. This is one we have to have. It's the voice of the customer, the patient. It's how the system is performing. I've seen people do some pretty good improvement projects, but they didn't measure the outcome because it was too hard to get. And the results often are, well, so what? So you made a nice improvement in the process, but so what? How's it impacted patients there? So always we need the outcome measure. That keeps us focused to make sure that our theory about the process measures are correct. We do need the process measures. As I said, some of those will be project level, and often they'll also be, almost every PDSA cycle is going to have a process measure, because the process measures tells us about the system we're trying to improve. If I'm trying to change the steps, I'm trying to add a new procedure in there, then I want to measure that and say, are we doing that? What's the reliability? Is it working there? Those are our process measures. And then the balancing measures are important from a sustainability point of view and a system point of view, because here we're going to look, our project's going to focus on one part of the system and try to improve it. Balancing measures look at the system from a different angle. So what happened to the system is we made a nice improvement in our process and outcome. What are some other things that could have happened? Often those are unanticipated consequences, other factors influence the outcome. Sometimes it can be a good thing that we see we have better health outcomes and also better patient satisfaction as a balancing measure. Staff satisfaction is often a good balancing measure for sustainability too. So what would my measurement system look like if I followed that advice? Well, here's an example from a surgical study. The outcome measure on the bottom right, they're trying to reduce the surgical infection rate, and so we see our outcome there. And then we have 3 process measures. Antibiotic selection, are we selecting the right one? We see that's gone up. Do we get antibiotics on time? And see that's gone up. And another process measure is the whole safety culture in the OR suite. So we see that's gone up. So we have made improvements in the process. Our surgical infection rates are heading down. And we have 2 balancing measures. What's this cost us? So we look at average cost per case, and we see that's stayed stable. And another balance, what about patient satisfaction? So these changes that we've made here impacting the patients, and that stayed the same. And so with a family of measures like this, we can declare we've had a nice success here. We've reduced the rate by changing these processes, and we haven't done anything to impact negatively the rest of the system. And so that's
Dr. Lloyd, just can you click on the slide there? Maybe we're just not seeing that next slide.
This was not showing up.
We're on the 3 categories of measures slide still on the screen.
Oh.
May just be taking a while.
Yeah, I think it's just maybe the internet connection.
There we
go. Yeah,
lovely.
Yeah. Thanks a million.
Okay. Sorry about that. Okay, so there's our outcome measure here, our 3 process measures, and our 2 balancing measures. Good. Okay. Okay, did that work? Next slide.
Yeah, perfect. Yeah, we're back on track. Thanks.
We had a little delay there. So what we just looked at are 6 run charts. So why a run chart in improvement? Why not just a table? If we look at a lot of research reports, if you look in BMJ quality, you'll see when they show the results of the study, they'll show the table. Here's the month and here's the results there. So why are we insisting on the run chart? And I think the idea when we see the run chart is we get a holistic view. So what we're trying, research is often focused on a very particular change. In improvement, we're focused on a system. And the first thing I want to see is that whole system. And so by putting data on its time series charts, run charts or control charts we'll talk about in a minute, gives us that big picture view. We see everything first, and then we hone in on the details. On this particular chart, we know we're trying to improve, we see where our goal is, but one point stands out right away. It's this point right here. Now, when we looked up on the table, we don't see that point. We don't notice it there. Okay? But now we see there's something very special, different here that happened in this period, and we want to make sure as we think about what's going on in the system is that we spend special time to understand that particular point there. So the run chart gives us the big picture as well as the specific details so we can see the system first. Here's a second example, this is from the Healthcare Data Guide in Chapter 1, and it looks at a study that was made. They collected data before the change on week 4, then they made the change on week 7, and then they waited for a couple weeks and then they tested again. Okay, so in the first test, the average daily cycle time was, delay time was 8 hours. It's right here on the bar, and after is 3 hours. So that's like a nice improvement. We cut it by more than half. Took the problem less than half there to do that. Okay, so that's the before and after. So why are we insistent on a run chart? Well, a run chart might look like this. We'd have the month 4 here at 8, just like we have down here, and we'd have the month 11 at 3, just like we'd have here. But then we also see month 1, 2, 3, 5, 6, 7, 8, 9, 10, 12, 13, 14 on that. So what are we gaining here that we didn't see in this picture? Well, I think the fundamental message in this case is case 1 here is the same. We had a system that was running, looked like about 8 before, and now it looks like it's running around 3 afterwards. A couple things we pick up, though, is one, there is some variation in the system. What's our prediction for week 15? It's not going to be exactly 3. We see that it looks like we're varying from 2 to 4 here in the thing. The real importance is that there could be other run charts. And so in the book it shows not just this case, but here's case 2, 3, 4, 5 other cases that all have one thing in common. Every one of these on the week 3, if you look, we're at 8. And at week 11, we're at 3. So these all, if we look at the before and after study for these would all have the same bar chart. But we see they have very different stories when we look at the run chart here. In the first case 2, the period before doesn't look any different than the period after. So what's the impact of this change? Maybe nothing. And what we see is we have a lot of common cause variation. There's a lot of variation in the system. And we have high months and low months, and just for by luck, we had a high month 3 and a low month here. Case 3, what's the impact of the change? Think of perspective here. As we look back, you know, it looks like this thing has been steadily decreasing the whole time. And maybe our prediction for week 14 is still going to go down. So maybe it has the change made a difference. Well, maybe we need to understand what's this trend going on in our system already before we recommend that change to others. Case 4, running about 8 before, make the change. It drops way down, but we look at the, you know, what's happened here is this change is not sustained. After week 11, it's you know, gone right back up. And our prediction, what would be our prediction for week 15? Certainly not 3, probably right back to where we were. It looks like it's gone back to 8. Case 5, it looks like there has been a change. Look, we're running at 8, and then we're doing 3, but it looks like the change happened right after we did our first baseline measurement, not before we made the change. And so this brings into question, once again, what's going on in the system. And then the last example, it looks like the system has been stable around 3 or 4 the whole time, but we had a special period here that when we did our baseline data, just by bad luck, we caught a period where we had higher results here. And so here's 6 different run charts that all have the same before and after measurement there. 8 on week 3, 3 on week 11. But they all tell very different stories. Our investigations, our discussion, do we recommend that others adopt this change would be very different depending on which one of these cases we have. So the richness of the run chart is a critical part and should be fundamental in all improvement projects. In addition to the run chart, though, there's 4 other tools that we actually use to learn from the variation in our measures. We're going to talk mostly today about the Shewhart control chart, but also a frequency plot or histogram that allows us to see the overall central tendencies and actually the shape of the data. So sometimes the fact that we're bumping up against 0 here and we're tailing out, this thing can be important. You know, sometimes we can't just take a straight average of this data and understand what it means there. This is for quantitative data. We use a frequency plot. For qualitative data, we use a thing called a Pareto chart. And a Pareto chart looks at just our different groups, in this case clinics, and finds out how often is this problem occurring in each of our clinics. And we see Clinic C, I, and G here, the first three, seem to have the majority of the problems there. And the Pareto rule is we expect 20% of the clinics to have about 80% of the problem. And we say, if we would say where should be our priority for first tests of change and beginning our work, in these clinics we're going to have the biggest impact and learn the quickest, because that's where the problems are. And our last tool, one of the most underutilized in improvement, I think we all need to use it more often, is a scatter plot. A scatter plot looks at the relationships between two measures, and almost always we should look at a scatter plot of our process measures versus our outcome measures. So somebody had a theory is that capacity in the unit affects the wait time. And so we can look at our monthly data, plot capacity on this axis, wait time on this axis, and we can see there is a relationship, that the wait times do go up, and especially when we get above 95% capacity, they go up to be very high. And so that's the scatter plot there is to validate that the changes we make. We can often see this on a run chart, but we'll see it much clearer if we do a scatter plot. So I want to concentrate mostly on the control chart, Shewhart control chart here. It is one of the time series methods there. So I think the minimum standard, when somebody said I've used improvement science on this project, this is what I would see for a minimum. They should have each of their outcome and process measures. There should be a time series where we have that reported monthly or weekly, and we have the results each month. We have our goal, we see the aim of the project, and we see what are the changes that we've been working on, that we've tested and implemented there. And I want those annotated and shown in the right direction. So an annotated time series chart, either a run chart as we have here, or we'll see in a minute control chart, should be the basic standard for saying. So I know IHI in their storyboards at their national forum, they get about 600 or 700 storyboards. 20 years ago, just a handful of those would have run charts on them. Today, that's the majority do if they're doing an improvement project. So before I talk about the control chart, actually those other four graphs we can all use with our basic knowledge of data. Control chart requires a different theory, and this is a theory developed by Walter Shewhart back in the 1920s. And Shewhart said that when I'm looking at variation in a set of data, I want to think about two types. I want to put it into two groups. Is this variation common cause or special cause? And common cause is the variation that's inherent in the system. It's there over time. It affects everybody working in the system, and it's all the outcomes of the system. In systems theory, when we make the statement, my system's perfectly designed for the results it gets, we're talking about it has a fixed set of common causes. Now, Shewhart originally called these chance causes. As he said, when we study these, it's difficult to pin down and say this is the one that's happening, because it seemed like they all combine to give our result here. A process affected only by common causes we call stable process or process in statistical control. The other type of causes are written just the opposite, just put a not in the definition. They're not part of the system all the time. They don't affect everyone, but they arise because of some specific circumstance. So we call this a special cause of variation. In Shewhart's original theory, he called these assignable causes because he said if we see one of these occurring, we see a signal, and we stop and investigate, we will be able to identify here is what this specific circumstance was. And so his method for learning is get a tool that allows you to monitor your system, and when we have common causes, continue to work on the common cause system, continue improvement projects. But when we have special causes, stop things and identify what are those specific circumstances. And often a lot of improvement can come just by the identification and removal or reaction to special causes in the system. So special causes are not part of the system. Anybody see the special cause in this picture? Okay. So often we need a tool to dig them out there. Sometimes it's not so easy to see the fox. So that tool, Shewhart also developed, and he called it a control chart. Called here a Shewhart chart. It's a statistical tool used to distinguish between variation in any measure due to common causes and variation due to special causes. And so the Shewhart chart takes a time series, takes a run chart, and does some calculations. Calculates a center line, a lower limit, and an upper limit, and those uses those limits then to bound where is the common cause variation. So the common cause variation is inside these limits with no unusual patterns there, and special cause are points outside the limit. The two we have on the right here. Now this, Shewhart originally called this a control chart because he was using it in an environment they want to control process at a certain level. In improvement work, we don't want to keep a process. We don't want stable processes because we're trying to change. We're trying to change the system, so we're trying to purposely maybe increase it. So this here, if we get a special cause like this, that's a success in our improvement project. So maybe a more descriptive of this chart for improvement work is a learning chart or a system performance chart. And so I usually just call it a Shewhart chart. So why do we need this complexity of a Shewhart chart? Why not just a run chart? So here's a run chart for a measure, and if we develop Shewhart's theory, here's the control chart on the right, and we see all of a sudden there's these special cause signals that we don't see over here. We don't have any mechanism to say these are unusual, but here we see that they are. Okay, and so that's what we're trying to do, is give us the opportunity to uncover these special patterns, these specific circumstances, and not just try to include those in our whole data. It gives a lot more precision on being able to detect different changes. So what would a Shewhart chart with common cause look like? It's one here on the right, where we see all the variation is inside the limits and no unusual pattern. And what would special cause look like is we'll see variation outside the limits, or maybe sometimes some unusual patterns we'll talk about in a minute. So how do you actually use a Shewhart chart? There's 5 steps we go through. We select our measure and our statistics. So I'm going to measure something that's happened, and I'm going to count. My statistic is going to be what % of the time does that happen. We have to have a method of data collection. So our operational definitions, how are we going to observe and measure, and what's the sampling procedure. If we change the method of data collection, we end up with a different looking control chart. The third is how do we group data? So we have measurements, how do we group those? Okay, what's our subgroup size and what's our frequency? So often in improvement we'll take monthly measures. So if we're looking at all the patients in the month, we might say, okay, we're going to have subgroup size around 20 to 30, and we'll measure, make subgroups once a month. We'll group all those measures together. But there's lots of other ways we could also subgroup. The fourth is which is the appropriate Shewhart chart, because there's not just one. We have different charts for different types of data. And lastly, we need rules for deciding do we have special causes or not. So that's the 5 components of a Shewhart chart. Now, how does a Shewhart chart actually show up on a project? I think this is a detailed graph on page 109. It's really how we think about your improvement project. If I wanted to apply Shewhart's theory here, how would I do that? Well, start off, we would select a key measure related. That's any of our outcome or process measures. Then we develop the appropriate Shewhart chart. We'll talk more about how to do that in a minute. And then the chart's going to answer the question, is the system we're trying to improve, is it stable relative to this measure? Do we have a stable baseline? If the baseline's stable, then we should move right into our project, which is working on common causes. And so we're going to be using test of change, planned experimentation, rational subgrouping to actually try out changes in the system. And almost always this is led by technical experts, because we're looking at the theory behind the system and the changes. So this is your improvement team. And then the result of our work is when we see a change idea that works, we need to change the system. We need to change the common cause structure, and we do that by adding a step or reformatting the system, changing job descriptions, changing workflow, and almost always this requires some level of management approval to remove the common causes. If the system in our baseline had been stable, then the problem is if we went over here and started changing things and we have an unstable system, we don't know if the impact is our changes or it's these special causes in the system. So the right strategy is to go, at this point, identify those special causes, understand those, use those to that. And often the people that best can do this are the workers in the system, because we're talking about a specific circumstance going on. Often the people closest to the system can identify those. And then when we make the change to remove a special cause, often that can be done without fundamental change to the system. Do that by local supervision, taking care of problems or issues or training or whatever we need, broken equipment, calibration, things that are going on. Then we go back, update our chart. Is the system stable? If it's not, we still work. So we work on this right side until we say, yes, the system is stable. Now we have a stable baseline, and we're in a position to make changes, because we can answer the question, how do we know a change is improvement? So this is the sort of the theoretical background of how a control chart plays this fundamental role in an improvement project. Just an example of special causes. It's a project I was working on at Cincinnati Children, and they published the results. It's one of the few publications I know in healthcare that's about a special cause. It's not about an improvement system. It's about understanding a special cause. And this was some work they were doing. They were monitoring bloodstream infections in the hospital. And over the last about 6 years, they've reduced that from about 3 per 1,000 device days down to less than 1 per 1,000 device days. And they did that by changing the common cause system. So that's all these are the different documentation of the different improvement projects. And in this time period here, we had 3 different improvement projects going on, further reduce this, tests of change we were running. But then all of a sudden, in August, we have a point that we didn't expect above the upper control limit, a special cause. Okay? So at this point, we have to back off our improvement work on the common causes and say, okay, what was the special cause? So we put our efforts on identifying that. And this paper goes into how they did that, but one of the things they did is a Pareto chart of what were the particular pathogens involved in these infections. And they looked at it during the stable period, January through July, in blue, and then they looked at it in the unstable period in August, and they saw all of a sudden this one particular pathogen stuck way out, and that led them to the particular unit where these special causes were. They were able to identify a device, a leaky device. They annotated them on a chart, spiral device evaluated that was going on that nobody had known about. To do that, that had been leaking. They removed that from the system, and so we went back. Now we go back to working on our common cause variation. This particular step here of reacting to, measuring, and dealing with special causes is a critical step in Shewhart's theory and in an improvement journey, and one that I think still in healthcare worldwide is not getting enough emphasis. Other industries, they're very clear about this. They learn from special causes. They take advantage of them. That's an area that we need to continue work on it, and is where we'll really see the value of the Shewhart method. Okay, now the last point in the 5 steps in the Shewhart process said, what is the rule to identify the special cause? And what we've talked about so far is Rule 1. We just saw an example of what's called Rule 1 here, a single point outside the control limit. All the rest of the data was inside the control limits. Here we have a single point outside to do that. That's our Rule 1. That's our most common. But there's 4 other rules that we should also consider that don't necessarily have any points outside. It could be all the variations inside the chart, but we still have some indicators of special causes. First one is a run rule. Run are 8 consecutive points above or below the center line. So some people call this a shift. We wouldn't be surprised to see 2 or 3 points above or below, but we wouldn't expect to see 8 in a row above. Let's treat that special, or 8 in a row below. And this 8 could include a point outside the control limit too. So we have both rules working there. Rule 3 is our trend rule. Trend are consecutive points moving up or down. So we define a trend as 6 points. And often you'll see people react to 2 or 3 points going up or down. And sometimes the impact of the trend rule having it is to slow down overreaction to perceived trends. And wait till we have our 6 points to do that. It could be outside the limit. Don't have to be. It could be inside. Fourth rule are in a stable system. Up here, we expect points maybe to go all the way out here and all the way down here, but we expect most of them to cluster around the center line and get fewer and fewer as we go out. And so what if we have too many points on the outer edges here? That's what this rule is getting at. And so it looks at 2 out of 3 consecutive points that are near the control limit. And the definition of near is the outer 1/3. So we could put some bands to see the outer 1/3. And so we see this group of 3 points there. 2 of those are in that outer 1/3. Here we have up here 3 points, but only 1 of them is outside. So that's not the rule. It works both ways. Here we have one from one side all the way to the other from one consecutive point. And so those 2 out of 3, don't need the 3 here, are indication here. So this one shows up important, adds some real good sensitivity that sometimes we don't quite pick up in Rule 1 here. And then the last rule are we don't have enough variation. We have consecutive points all hugging the center line to do that. So 15 in a row, all in the inner 1/3. Number one reason we see this is measurement problems. People aren't collecting data properly, and so somehow we're not seeing the natural variation we'd expect in that data. So here's an example of a chart looking at just counting the number of needle sticks. And we see here on 7.5, we have a special cause Rule 1, outside the control limits. And then during this period here, we have a Rule 2. We have 9 consecutive points in this case, all below the center line here. So both these are special causes. I think the straight point is special doesn't mean good or bad. This special, we had a lot of needle sticks, that's bad, but maybe we identified the problem, put together a new test, and we implemented a test here. Here we have a special cause that's good. It's an indication of that we've improved the system. So here's 4 charts. Take a quick look at those. You see any special causes in chart 1? Now jump down to chart 2. Any special causes here? Take a look at chart 3. And chart 4. Okay, so let's look at those individually there. So chart 1, it helps. So circling the special causes then highlights that so we can learn from them, and then we put our annotation as we identify them. So there's 2 Rule 1s, and then we see our trend rule, 6 points in a row moving up. Chart 2, we had 1 special cause, Rule 1, but then we also had 15 in a row, all hugging the center line. So somehow the natural variation in our system has disappeared here. That's special. It often could be good, but often could be a data collection problem. In chart 3, almost everything's special because we have 8 below, 8 above, 8 below, 1 down here. So lots of these points are affected. So we've had what we call shifts in the process going on. We want to identify and understand these shifts. In chart 4, don't see anything because it's all common cause variation. Okay, so that's an important step in the analysis is once we have our control chart, then the calculation limits is identify those special causes. Okay. Now the most complicated step in the control chart, I'm going to go through it pretty quickly so we have time for questions, is do I have the right control chart? And there's not just one Shewhart control chart. There's 5 basic types of charts: C chart, U chart, P chart, I chart, X bar, S chart. And then there's some other advanced charts to do that. And why do we need all these charts? It's because we have different types of data. So in healthcare, a lot of our measures are continuous data, things like time, money, volume counts, laboratory tests, things that we're measuring on a scale. But then other types of measures, we're just counting or classifying. We're saying, yes, it either worked or didn't work. That's a P, that will lead to a P chart, or we're counting a problem. We had an infection, and we look at, do we have an equal area? We can do a C chart, like with needle sticks, or do we have different opportunities, like how many line days do we have? And we'd make a U chart, which is a rate chart. So on improvement projects, often I'll see all 5 of these charts being used here. For continuous data, it's things like waiting time, length of stay, patient's weight, time to complete a procedure, temperatures. Classification data, we're putting things into categories. We did a surgery, do we have complications or not? We gave a dose medication, did we have an error or not? Patient was discharged from the hospital, did they come back, readmitted or not? And so all these are where we're putting things, counting a problem or classifying them into two categories there. The eye chart is most useful for continuous measures when we're going to have a look at each data point by themselves. And examples, patient-specific data. So some ways because we don't have a way to organize them, but most often it's the measures can be formed infrequently there. Here's an example of an eye chart from a paper that was published this year. It's from studying the ankle rules to get radiology and how long it takes. And so the chart here is just individual patients. So individual patient 1, 2, 3, 4, all the way through 75 patients. So each of those has a waiting time, and we're looking at the individual waiting time. Okay? So this is over the whole life of the study. They had about 75 patients in the control groups. We see a pretty stable process, one special cause here. So learning there, 2 out of 3 plus the outside the control limit. The other way we look at continuous data is X-bar and S charts. X-bar and S charts are going to be much more powerful and much more sensitive than R charts do that. Here we're going to form subgroups. We're not going to look at each data. We're going to group them. And it might be groups by day or by type of patient or by other categories there. Here's an example. We're looking at a radiology day test turnaround. And each day, June 7th, we did 5 tests. Okay. And June 8th, we did 3 tests. We're going to let each day be a group, okay? And so each day we're going to calculate the average and plot this on the X-bar chart, and we're going to calculate the standard deviation and plot this on the S chart. And so these two statistics, this average chart will be much more sensitive to X changes in the system, and then the S chart will pick up changes that involved an individual patient or an individual radiology test here. Here we see special cause in June, and we can look at the data in the June and see where we think that special cause is. Here's an example of X-bar S charts from the improvement literature. They're looking at a lung protective ventilation. Do we have the right tidal volume for that? And the goal was trying to reduce those, and they have different time periods. So this is 3 different time periods during the surgery. And you can see, so we've broken those into 3 groups. So here's the average performance of the system, and here's the standard deviation. Standard deviation would be individual patients down here. So what X-bar S chart, a more complicated chart as we can see here, but it's much more sensitive. It allows us to separate the variation from individual cases, study it in the S chart, and then leave the changes to the system, which is what this paper is about, trying to do this reduction in each case up in the X-bar chart. It's a much more sophisticated chart, but one, if we really want sensitivity in our results, that we ought to try to be using. You can also subgroup in different ways. It doesn't have to be by time. This is an example of an X-bar chart looking at length of stay by providers across the bottom. Okay, so that's our 2 charts for continuous data, and then we have 3 charts for attribute data. The P chart for classification data, whether or not we have a constant subgroup size, and a C chart if we have a constant subgroup size, and a U chart for count data when we don't. C chart, not that rare. It's pretty rare because we don't always have a count, but it's sometimes looked at overall systems there. Here's a P chart on readmissions rates. Okay, so this is an example of an improvement project where they got a baseline data at a stable system, so then they started making their changes, and then they show after they had special cause, signals had 8 in a row below, then they recalculated the limits here. So that's a P chart, looking at what % of patients are readmitted, and good for reduction. When we regroup, if we have our subgroups are qualitative data, like this is looking at different hospitals, and we're looking at MRSA in the hospital, at MRSA rates. Sometimes when we order those by the subgroup size, so the biggest hospitals out to the right here, the smallest there, then our limits because they're changing, create this funnel look. So that's often called a funnel plot. So if you see somebody talk about a funnel plot, that's probably a P chart or a U chart with the subgroups ordered by size here. Okay? I think as we study variation across our system, find out which providers or what hospitals or what clinics have special results, this is the funnel plot's an excellent way to do that. We looked at the C chart earlier. There, we make an assumption that the opportunities for needle sticks in the hospital are the same each month, so we just count the number to do that. More common for rate count data, though, is a rate chart. In a rate chart, we're looking at the, this is the CLABSI bloodstream infection per 1,000 line days. We see an improvement there. This is from pediatrics last couple months ago. Now, those are the basic charts. We need to use those on a project all the time, but there's also a bunch of advanced charts, and two of them in particular that I find us using all the time. In fact, when we do a second edition of the Healthcare Data Guide, we're going to include these as basic charts because we're finding these used a lot in healthcare. And it's if we have rare data. If a lot of times, if I'm taking monthly data and some months we plot 0, we get a chart patterns that look like this, it's difficult to learn from. And so what we want to do, instead of plotting each month, we want to plot each time we have an instance, and it's rare, and then count the number of days or number of cases between them. And if we count the number of cases between, we end up with a thing called a G chart. So there's a G chart looking at how many days between adverse drug event. Okay, so we have our baseline, and then we can see our improvement here. Now the difference in this chart, we want it to go up. So our arrow's pointing up here because we like to increase the days between, or the time or the number of doses between. So that's looking at cases, and then the T chart looks at just the time. So how many days between foreign objects. So we're trying to reduce foreign objects or rare events. So each time we have one, we plot, well, how many days since we had the last one? And we used to run about 20 days, have one about every 20 days. Now we're running about 84 days. So we've made a nice improvement there. And so this chart, the T chart and U chart have advantages. We plot each time we have an instant, and we get a continuous measure, so either counts opportunities between or days between. And I think it's for a whole lot of healthcare problems that are relatively rare events, certainly at when we go to one unit or one hospital level, these charts are very useful. So the general advice on an improvement project is start with a run chart until we have enough data, about 12 points, calculate trial limits, and then update our limits. And then set about, once we have calculated our limits and extend those, set about on our improvement work. Now we have a sensitive way to detect, we see a special cause, and we say, okay, that's the impact of our improvement, going in the direction we want. And then we recalculate our limits at the new level, and now we move either continued improvement or into a holding the gain environment there. So this is the patterns that we expect in an improvement project, what a control chart look like. A stable baseline, a period where we forced it out of control, and then a reestablishment of stability at a higher, better level that we have there. Okay, so lots of good ideas there, lots of stuff to cover, so let's maybe take time for some questions here.
Thanks a million, Lloyd. Great webinar, jam-packed with some really good tips there for us all to take note of. There hasn't been a huge amount on the chat box, actually, so if anyone has any questions or comments, now's the time to get typing. Sonali has asked if there's a recording of this webinar. Yes, this is being recorded and will be available on the qualityimprovement.ie website, which we'll put into the chat box now for you, okay? And the slide set will be available as well, because there is a lot of information. We probably need to go back and listen to it again and consolidate everything that Lloyd has given us. Veronica Hanlon has asked, what in your experience have you seen as the best way to measure the effectiveness of a quality improvement education program or specific training intervention? Yeah,
so I think it's really what's the measurement we're going to use. And I know in the IHI programs I'm involved in, we measure at 4 levels. Some people call it the Kirkpatrick method. So we measure is how did they have a good experience in the training. So their basic feedback with the training process. Did they learn anything? And so we answer that with a before and after test. So we say, what did they know at the beginning, and now what do they know at the end? So we can do that with some kind of before and after test. Did they actually apply what they learned? And that's a process measure. Did they actually go work on, for learning how to do a procedure? Did they actually do that procedure? We monitor there. And then the fourth level is the purpose of doing that procedure, the purpose of the training program was, and so the level is, do we actually see the outcomes change? And that's the hardest to do. So as you step up to level 1, 2, 3, 4, almost all our training we try to get to level 3, which is the process. Did they actually change the behaviors, processes? And then level 4 is the outcome. So think about, in a training program, think about all 4 of those levels that we should measure as we set up.
Yeah, Lloyd, Philip here. I mean, it's great talk, and thank you so much. And we've been using what we've learned from you here in Ireland, and historically we've had a performance report populated by sheets of data, point in time compared to the previous point in time in the previous year. So I think your slide showing the number of things that can be happening in the interim and the different explanations that they lead to are very relevant for us. But most recently, 2 months ago, we've had our first Shewhart charts included in our performance report. So I had the whole leadership team pause and reflect on them and applaud them, and hopefully they're becoming the norm. So there's another question there in relation to
congratulations. Congratulations on making that happen, Philip. That's great to hear.
Thank you. Yeah, we're getting there. We're getting there. And there's a question here, which is an interesting one about very rare and maybe severe outcomes in smaller units are obviously going to be very rare outcomes. Things like, I guess, maternal mortality in a smaller maternity unit, or indeed in any maternity unit, or postpartum hemorrhage rates even. They may not be useful for affecting improvements, and therefore should we, in those kind of instances, be using more process or look for different outcomes maybe?
Yeah, I think I'll go back here, like this example is something that's only occurring every 20 days. So in my hospital, I'm only one a month. So the result is it's still something we'd like to have never occur. And so I think still the right way to monitor that is with a T-chart or G-chart over time. But it is going to be slow. So we're not going to have them very often. But we still will, if we can make improvements, we can still see those. Of course, our ideas for improvement should come, and our feedback for improvement projects need to come from the process measures. So we need to have the process measures of the things that we believe could reduce this further, even though it's like maternal mortality, a very rare event, and we should be measuring those processes to get our feedback loop. But still long-term, keep the outcome on a time between chart so that we can know over time, yes, these things are making a difference.
Great, yeah, that's what I thought. That's excellent. There's a question which might be a little bit hard to kind of answer just briefly, but can you explain how to calculate control limits?
I think my recommendation is go to Chapter 5 in the Healthcare Data Guide or get some software. But the whole idea is Shewhart called these 3 limits. And so the center line is going to be the average of the statistic that we're plotting. So in my example here, the P chart, the average of these statistics will be a weighted average, will give us a center line. And then we're going to calculate what Shewhart called a sigma. And a sigma is a measure of variation that only includes common cause variation. So it's not our traditional standard deviation calculation. Calculation, how can I actually use this data and calculate the common cause variation? And so for each of the types of charts, there's a very specific way to get the sigma. And that's why, to go through each of those as Phil said, is a complication. So you have to actually go look at those formulas. How do we get the sigma? And then the limits are going to be plus or minus 3 sigma. So we'll measure 3 times the sigma for there. And that without making any assumptions that we think almost commonly we're going to stay inside those limits. And it would only be a special circumstances when we would go outside. Okay. So, almost most people that are using control charts have programmed those in software, they're actually not complex. So you can take an Excel spreadsheet where you have data and actually look up those formulas and plug them into your Excel and calculate the limits there. But there's different ones for the I chart, U chart, to get the specific sigma is the key.
And the other thing then is try and should control limits be updated, and I guess also shifting the midline. I guess that's about shifting the midline as well, isn't it?
Yeah. So the overall answer to that is that any time that the previous limits are no longer appropriate, and when that's the case is usually, like in this example, when we have a signal that something special is going on, and we believe that special is the changes that we're making. So maybe say right here at this point, I'm going to decide we need to recalculate our limits here because we're way above the upper control limit. I might decide that back here. So now I need to collect 12 points, and then since I have 12 points to recalculate the limits. So I made the decision right here that the improvements that we're making have resulted in special cause signal, and that signal says, okay, now I need to recalculate. Now, the decision about exactly where to start the calculation, should I start here, should I start here, should I start here, that should be the subject matter that understands when did we actually implement the change, when did the shift actually take place. And we use that to decide, okay, starting here, we'll recalculate the limit.
Great, that's a really good, really clear answer. I was very struck by your distinction between measurement for improvement and measurement for accountability. I think we're still largely logged in the kind of measurement for accountability space, which has its role, obviously, because we need to be accountable for our performance. But I think the distinctions are very important for everybody listening online and everybody who watches this subsequently as well. That we need to be looking at measurement for improvement as well to give credit for when we are improving things as well.
Right. Exactly. Good.
Great.
And just keeping this is people's lunchtime, and so we're at 2 o'clock now. So unless there's any other burning questions there, we might finish off shortly. Just to say, if you go to qualityimprovement.ie, there is measurement for improvement, a section there where we have a team within the Quality Improvement Division who work specifically on this, and you should definitely check out their resources online. Lots of nice tools on run charts, calculating control limits, etc., etc. So do check those out. Also, if you go to, you'll see the framework for improving quality and also the knowledge and skills side there. There's no further questions, so I'd just really like to thank Lloyd for getting up so early and facilitating us with such an excellent webinar. And we hopefully will have you back again sometime soon. Thanks a million. You've given us plenty of food for thought. And sadly, but maybe it's a good thing, this is the last webinar for the summer break. So we're taking a little bit of a break now for the summer to, I suppose, redesign and think about how we're going to plan out next year's talk time. So it'd be really, really helpful if you would please fill out the Survey Monkey. It shouldn't take more than 5 minutes. We'd really like your feedback on what worked well, what didn't, and your ideas. So please fill that out for us. And thanks a million for joining. We did a lot of good participation today and look forward to you all joining again in the future. And Lloyd, thanks again for your time. Thank you.
Thank you, Lloyd, for everything you've done. Really appreciate it.
Bye. Thank you.